Hi guys, this is Reassessment 8 for the standard ORN potential energy, and I chose to do question 28 in chapter 7. And the question asks, an airline executive decides to economize by reducing the amount of fuel required for long distance flights. He ordered the ground crew to remove the paint from the outer surface of each plane. The paint removed from a single plane has a mass of approximately 100 kilograms. And the questions and what they're looking for is, in part A, they are asking for if the airplane cruises at an altitude of 1,200 meters, how much energy is saved in not having to lift the paint to that altitude. Okay, so I have my known values written down right here. The mass of the plane being 100 kilograms, the altitude, or you can call that the height that the airplane is up, is 1,200 meters, and you know there's gravity force acting on that plane, so that would be 9.8 meters per second squared. So let's go back to what the question is looking for. It's asking for if the airplane cruises at an altitude of 1,200 meters, how much energy is saved in not having to lift the paint to that altitude. So being that they're looking for energy that is saved and that the airplane has stored energy now, we can use the formula for calculating potential energy, which would be PE, potential energy, is equal to mgy. The y can be considered as h, the height, well, because it's going up and down. So in the y-axis, so we can plug in our numbers. We can plug in 100 kilograms times 9.8 meters per second squared times 1,200 meters, and that gives us 1.176 times 10 to the 6 joules of saved energy. All right. And part B is asking for how much energy is saved by not having to move the amount of paint from rest to cruising speed of 250 meters per second. So right here they're asking for the amount of energy saved whenever you don't have to move the paint from rest to cruising speed. So that kind of gives me a hint that they want us to use work is equal to the change in kinetic energy formula. So what I did here was I did W is equal to delta KE, which is the change in kinetic energy, and then that can be rewritten as 1/2 mv squared, 2 being final, minus 1/2 mv squared, 1 being the initial. Being that the initial is starting from rest, we're going to consider that as 0, and so that just gives us 1/2 mv squared 2, or final. So I can plug in my values. I can plug in 1/2 times 100 kilograms being the mass and the velocity being 250 meters per second squared, and that gives me 3.125 times 10 to the 6 joules.